a substance with a sight and smell that disgusts us. Something we're hardwired to avoid. But look beyond our disgust and we might see it's a substance with amazing potential to be the ultimate renewable resource, capable of solving some of humanity's greatest challenges. Its gases have the potential to generate power. It's full of nutrients that are essential to agriculture. And it contains medical secrets that could transform healthcare. I'm talking about human waste, about sewage. I'm Dr. George McGavin, with exclusive access to one of Europe's most advanced sewage works. I'm setting out to prove that poo could be priceless. It's black gold, isn't it, really? Uncovering how a revolution in the science of human waste could transform our lives. So you could supply gas to 28,000 homes. Bold enough to join me on this quest is material scientist Dr. Zoe Laughlin.
It doesn't smell in any way disgusting.
I want to get up close and personal with what we flush away.
It's just like a horror hatch into raw sewage.
It's not pleasant.
To get to grips with exactly what's in it and discover the mind-boggling microbiology being used to clean it.
Whoa, it's massive!
Look at it. With a pop-up lab based at the Sewage Works, we're even going to search for new life in sewage that could have amazing medical properties. You have discovered a biological entity which is potentially a lifesaver.
Every new one that we find is another patient that we can potentially treat.
Join us on an incredible journey into a hidden world where we face up to our feces and uncover the secret science of sewage. Pretty much all of us will flush something down the toilet several times a day. Our developed world affords us the luxury of never having to think about it again. A cistern full of water carries the unmentionable it away into a hidden network of pipes. But where is away? What we flush has to go somewhere. And that somewhere is a place like this. This is Minworth Sewage Works on the eastern outskirts of Birmingham. Run by Severn Trent Water, it's one of the biggest in the country. A square kilometre of pipes and pools dedicated to processing the wastewater of Birmingham and the Black Country. Every day it's on the receiving end of 1.7 million people's fecal matter. This massive treatment plant is the ideal place to investigate how stripping resources out of sewage can turn it back into water clean enough to return to the environment. We're going to take you through each stage of the process, beginning at the point where the raw sewage arrives on site, the inflow, which is where I find Zoe. Zoe, I'm feeling rather overwhelmed now. Our job is to persuade people that this is a valuable resource.
It's absolutely disgusting, but I can't take my eyes off it. Gives a whole new meaning to poo sticks.
At peak flow, this is nearly 12,500 litres a second. That's 1 billion litres a day.
But it hasn't rained for days, so this is just normal toilet flushing, sink filling, drains on the road. Yeah.
Regular sewage.
Regular sewage. This isn't a storm flow.
I mean, this is just humanity. This is just the waste product of a large number of people. That's all it is. But when we say raw sewage, what do we mean? What does it actually comprise of? Perhaps what few of us realise is that sewage plants don't just deal with human waste, it's all the water we use. Anything that goes down the sink, from the dishwasher, the washing machine, the shower, the bath, anything that ends up in the drains, all of it.
So what's in this disgusting torrent that's a resource? And what things shouldn't be in there at all? To find out, Zoe set up a demonstration at our pop-up lab to deconstruct sewage.
What I've got here, George, is a tank that can hold up to 140 litres of water.
Now that's the volume of how much one person uses every day.
And send it to the sewage treatment plant.
Right.
And we send it full of muck. And what I'm going to do to it is add in all of the things that we put down the drain over the course of a day.
30% of household water is used for flushing toilets, so that's where we'll start.
This is 2 litres of urine. This is what an average adult would produce,
Alrighty.
you know, in a day if you're well hydrated.
Yeah, all right.
Now, in this instance, this is apple juice.
And that contains lots of nitrogen, uric acid, urea, creatinine, all those things that are very rich in nitrogen, which you have to get out of your system.
Time for a poo.
Time for a poo.
Time for a poo. The average adult produces 1 poo a day of 250 grams in mass. This is soya bean paste, which is an industry standard for simulating turds in a toilet. So I'm going to put in
250 grams.
250 grams. 231.
Not bad.
Not bad.
Not bad.
In fact, this is quite wet, which isn't far off what a real poo would be like, because 75% is water.
Yeah.
And then of the stuff that's not water, you've got half of that just as biomass, really. So bacteria and
protein.
Protein. Fat. If you've got too much fat in your diet, you'll get the floater.
The protein and biomass in poo equals potential energy, but as a possible resource, it's now massively diluted. This amount of poo in pee in this much water means that human waste makes up less than 2% of raw sewage.
There's something
Brilliant.
marginally convincingly gross about it, now it's in the water especially.
But we also add around 25 grams of toilet paper.
Sort of wrap it around the handful,
no,
which is
that's
bad for the
terrible.
plumbing, but it is the natural way in which
Right.
people go.
An average person uses 50 sheets a day.
This is predominantly cellulose, so this is a natural fibre which will break down pretty easily.
Another 30% of our water use is from the bathroom sink and shower, over 40 litres worth. On average, we each add an estimated 30 millilitres of personal hygiene products a day.
There's a bit of shower gel. 1. Oh, I did wash my hair.
Shampoo, toothpaste.
There we go.
Okay.
These all contain surfactants, chemicals that act as foaming agents. Along with sodium hypochlorite in bleach, these elements will be diluted and break down.
Round.
bleach.
That'll do.
Water use in the kitchen makes up a further 30% of sewage, and here we can add up to 50 millilitres of detergents and cleaning agents. All these products are designed to break down in water, but not everything that we pour down the sink will dissolve.
Sort of sauces and oils on plates definitely go in.
In particular, fats.
And that's what you shouldn't put down the drain, really.
No, but when it's in a liquid state, you can see how people do.
Yeah.
What we can see here is how, crucially, the molecular characteristics of fat prevent it dissolving in water. And in a sewage pipe, it can congeal, causing fatberg blockages.
Once it sort of hits the sewer system, the turbulence of the flowing water churns it up. So to simulate that,
Wow, that is.
I get
that
the
is a
big
mixture.
blender. See, now it's starting to go browner.
Wow, the turds are definitely being agitated.
That's what I like to hear.
Yes.
Right, there we go.
I want to compare what we have created, what you have created, to a bottle of intake water, which we got from the plant. And it's
It's not far off.
it's not far off, is it?
At the beginning, this was a valuable resource. It was clean, safe drinking water, and now I've just come along and contaminated it and made a problem.
But in that problem there's energy, there's minerals that can be reclaimed, there's stuff in here that's worth having.
But imagining there's stuff in sewage worth having goes against every natural instinct we have toward it. We are disgusted by feces. It's a socially evolved behaviour. Babies will play in it, but we learn that excrement is dirty. It makes you ill. Scientifically, we know that sewage teems with harmful bacteria like Salmonella and E. coli. Even traces of COVID-19 have been detected in it. We pass it out in our poo. Our bodies are designed to get rid of it. But does that mean that all viruses and bacteria in us and in sewage are bad?
Now, this is where the science of shit gets really fascinating. The bacteria in our intestines, the gut microbiome or flora, number not in their millions and billions, but in their trillions. And science is just beginning to understand it. The bacteria in our gut are a complex and unexplored universe, individual to each of us. Yes, they help us digest our food, but they also protect us from diseases. There are particular types of bacteria in our intestines that kill off harmful pathogens.
But when we get sick, often conventional healthcare's default response is to treat us with antibiotics. This can kill off all the bacteria in our gut, good and bad, sometimes leaving us even more vulnerable to disease, especially superbugs. Just a tiny sample of poo contains millions of unknown good bacteria and even viruses capable of fighting off disease. And this is where sewage has the potential to offer one of the most counterintuitive resources imaginable: medicine. I'm being joined by a true pioneer of the science of sewage, Dr. Ellie Jameson. And right now, this world-class scientist is rather bizarrely fishing in sewage for a nanoscopic organism she calls a phage.
So this is where the sewage first comes into. Oh, I've just got a bit of lumpy stuff in there. Into the sewage works. This is where all the bacteria and the phages are.
This is an enhanced photograph of a phage taken with a powerful electron microscope. It's an entity so small, it's measured in nanometers, a millionth of a millimeter.
What is a phage?
So it's a virus which only infects bacteria. So it can't kill any plants or animals, but it will kill the bacteria.
Why do you want to work on phages? What use are they to us?
Well, to us, so I'm interested in bacteriophages which kill superbugs. So the superbug that I'm interested in is Klebsiella, and that's becoming more of a problem in hospitals. So it's causing pneumonia infections, it's causing urinary tract infections, which can go on to cause septic shock as well.
Superbugs like Klebsiella and E. coli are bacteria resistant to antibiotics. But science has discovered that phages will act against them.
How do they attack a bacterium?
So first of all, they've got little receptors on the legs, so these bits which come down, like the lunar lander. So the bit which would land on the moon first, the lunar lander, is the legs which recognise the bacteria.
Right.
And when they stick to a protein that they recognise, they bind to that, and then they can inject their DNA or RNA inside that bacteria.
Straight into the bacterium?
Yeah.
And that basically takes over the bacterium completely. And that will help us to treat infections that we currently aren't able to treat.
Yeah, so especially in Klebsiella, there's a lot of Klebsiella which pick up antibiotic resistance, and there's some which are multi-drug resistance as well, so resistant to all the common antibiotics that we use. So by using bacteriophage, these will kill the bacteria, but also they'll help our existing antibiotics to work better, and so we can use them in combination with antibiotics to cure a patient. So instead of killing off everything in your gut, like when you have antibiotics, they will just target the thing which is causing the problem in you. and leave all the other bacteria intact.
Science has known about the existence of bacteriophages and their therapeutic properties for decades, but the targeted hunt for them in sewage as an alternative to antibiotics is a relatively new approach.
This is a churning mass of all sorts of bacteria and viruses, and out of that soup, you want to extract something that could be the next wonder drug.
Yeah, that's what we're looking for in here. There could be loads of things in there that nobody's ever seen before that could kill the next bacteria, which is going to cause problems. So it's really interesting to find out about these things and get as many as we can, the different ones that to help us help medicine and improve the future of medicine.
Ellie's returning to her laboratory for now, where she'll clean up and analyse her sewage sample for phages. I'll catch up with her later to see if she's found any and if they're active against any superbugs.
Meanwhile, Minworth's never-ending torrent of sewage keeps on coming. And I want to get a closer look at the engineering systems being used here to process it.
The material science and engineering challenge here is staggering. Bearing in mind that sewage is always flowing and wastewater always needs cleaning, I want to see where this process begins.
A secret of sewage science is to always keep the effluent moving. The architecture of the plant channels the wastewater from where it arrives at the inflow towards stage 1 of the process, an area known as the screens. This set of massive structures are the first point of sewage filtration. Keeping the system operational is technician Andy.
Oh my God. Andy, is this the raw sewage coming in?
Yes, this is the raw sewage coming through these screens. The flow, everything comes down the drains, through the kitchens, toilets, comes through here until it hits one of the screens over here.
I can see lumps of brown.
Anything that goes down the drain.
Inside the screen structures are angled caterpillar track-like sieves, constantly rotating. The sewage flows into the lower part of the track. Large solid objects like plastics are lifted to the top and fall into the collection bin below. But anything liquid or small enough, including poo particles, pass straight through the 6mm size holes in the sieves.
You'll be amazed how many car wheels come down here and tyres. There's a football that we took out this morning. There's a basketball in one of the ones over there, which we will get around to later.
I want to take a closer look at the inner workings of these screens. But as Andy opens the inspection hatch, a true horror of the sewage system is revealed.
Oh, hell's bells.
Wet wipes.
As you can see, most of this, a lot of it is wet wipes. That is wet wipes.
Wet wipe. A little bit of plastic. So it's not the cellulose of toilet paper isn't the problem, it's the heavy weave and the denseness of the wet wipe.
That's right. It doesn't break up, it just shreds into smaller pieces which don't go through the screens, they end up here.
Wet wipes have only become an issue in the last 20 years. Now, nearly 15 billion are used in the UK every year, and many get flushed, contributing to 75% of all sewer pipe blockages.
And actually, the closer you look, the more you see. There's a huge amount of human hair, almost felting it all together. Wow. It's just like a horror hatch into raw sewage.
It's not a pleasant view, no.
How long have you worked here?
17 years.
Do you feel like you've become used to it? Is there something, what's your immune system like?
When you open it up and see a dead rat hanging by its tail, no, it's still a bit of a shocker.
The sewage passing through the screens is now a filthy sieved soup. With all the elements mixed together, it's harder than ever to see this as a resource, especially for generating power with. And why even go to the effort? The answer is we need to. With fossil fuels unsustainable, renewable energy sources offers a solution to powering the planet. Wind and solar can be unpredictable, but sewage is constant. In the UK, we produce 11 billion litres of it a day. The single biggest volume of human waste we produce is urine, 2 litres a day each, and it's rich in minerals. So do these minerals have a value as a resource? And could we use them more efficiently instead of flushing them into the sewage mix? Could there ever be such a thing as P-power? I've come to Bristol, where an incredible new biotechnology has been developed. One capable of generating clean energy from a resource we all produce. Time for me to spend a penny.
Partly because I need to go, as a gentleman of my vintage often does, but more importantly, because I need to charge my mobile phone. This is going to power my phone.
I've come to a state-of-the-art research facility full of mysterious wired-up devices and whirring dials. But centre stage in this lab is a urinal. Above it is a circuit board and a phone charger. I'm told all I have to do is to plug my phone in.
So let me stick it in.
And pour my pee sample into the urinal.
Honestly, I can't believe this is going to work. I mean, it's like one of those things like, oh, I've never done this before. And switch on the current. Oh, there you are. It's charging. Wow.
The magic happens round the back in this unlikely looking bank of battery-like fuel cells. Its inventor, Professor Yannis Eropoulos, is explaining how these cells work.
This is known as a microbial fuel cell technology. It's using live bacteria that generate electricity.
So what is in my urine? What is it in there that they can use?
It contains carbon, phosphorus, potassium, sulfur, magnesium, creatinine, and these are elements that the microbes will require to continue living and growing.
The fuel cell's central tube is porous ceramic that microbes colonize and urine permeates through. As elements in urine are consumed, electrons generated by the microbes are picked up by the cell's opposing wire coils.
Where do the microbes, because there has to be particular sorts of microbes, not just any bug will do. How do you locate those?
There's a plethora of microbes out in the natural environment, and this is exactly what we have been using. So what we would tend to do is collect a sample from a pond or a lake, a river sediment, bring it in the lab, and then put it inside this microbial fuel cell, which is connected to the circuit that's drawing current and it's demanding to have electrons flowing through.
Each fuel cell produces 1.5 volts, but linked together in series like batteries, and you boost the output. But Yannis's vision for this amazing technology goes much further than a phone charger. He's scaling it up as a unit that can be built into the fabric of houses and instantly draw on urine to provide electric power.
If you can imagine just taking a standard brick and converting it by simply integrating microbial fuel cells and continuously taking the household wastewater, and then we generate the electricity we require for charging devices, lighting up rooms, DC refrigerators would be the future.
But how far in the future are we talking? Whilst all this kit might look like a prototype, Yannis's technology is very close to being rolled out.
The work has been funded by the Bill and Melinda Gates Foundation, by the UK PSRC and by the European Commission. And from those funders we have got our objectives, which are to deliver the technology outside of this lab to the society.
For this technology to benefit UK homes, separate unisex urinals and plumbing add-ons could pipe pee directly to the cells. In the quest for diverse energy sources sitting alongside solar and wind, this has incredible potential, and there's no doubt it's renewable.
If we have microbial fuel cells in the walls, then we are tapping on a ubiquitous and never-ending fuel.
It's so exciting. The whole thing is so exciting. It's just, this is what science should be about, especially now. Oh my goodness, we need this stuff.
I couldn't agree with you more.
Well, I absolutely love that. In terms of what we're investigating, is there any value in our waste? This is it answered and realized in a way that is truly inspiring. You can imagine a future when all of us will have microbial fuel cells built into the fabric of our homes, generating power from our pee at source. But you know, I can't help wondering if generations from now, our descendants will think we were totally insane to simply flush our waste away.
Back at Minworth Sewage Works, the waste we've simply flushed away is in full flow. Having come through stage 1 screens, where the largest solid materials are taken out, the main solid elements left are millimetre-sized poo particles and grease from cooking fats. But how can any of this be isolated and extracted for use as a resource from such a finely sieved soup? Now the sewage is channeled from the stage 1 screens into stage 2 of the treatment process, the settlement tanks. There are 22 of these massive circular tanks for this second part of the processing stage, and I want to find out exactly what's settling in them. Compared to the gushing torrent at the inflow, everything's got rather sedate. Just like Zoe's demonstration earlier showed us, I can see fat and grease floating on top of the sewage. But as Minworth's senior technician Phil explains, the secret science at this stage exploits how sewage behaves when it's not flowing so fast.
So it's a very simple idea. Heavy stuff sinks to the bottom, and then anything that floats is grease or
yeah, you
fats.
get the fats on the roof, so you see in the tanks there,
yeah.
We have scum traps, so they'll just go into a well, and then we'll take that away. All the grease will naturally sit on the top, and the scraper will paddle it down into the...
And that big bar there is just constantly moving.
Yeah,
fairly slowly.
Yeah, very slow.
But it's below the surface of the sewage in these tanks that the crucial settlement process of this stage is taking place. Like sediment in wine, gravity takes effect and millions of broken up poo particles are simply sinking, forming a sludge in the tank's conical bottom. The slowly revolving rake arm scrapes the sludge into a collection tank below. The now much cleaner sewage water above filters over the tank's baffle and is channeled onto the next stage of treatment. But what happens with that settled sludge collecting underneath the settlement tank? I'm going to get a closer look via an inspection well.
Okay, you prepared?
Yeah.
Ready?
I'm ready.
So far, the smell on site hasn't been that overwhelming. But the settled sludge absolutely stinks.
Stand back.
Well, I think I will, yeah.
Now that the poo has been separated out of the sewage, gases like hydrogen sulfide are more concentrated. There's a spicy top note of indole and scatol produced by bacteria that's particularly offensive. But there's also a gas in here which is odourless, one that has phenomenal potential as yet another energy resource. Methane.
The crucial thing about methane is it's volatile and incredibly flammable. So is there a way we could somehow extract the methane in here and exploit it as a resource? And if so, how?
The sludge from the settlement tanks is piped across Minworth to 16 giant silos called biodigesters. Acting like pressure cookers, conditions inside the biodigesters are engineered to force a bacterial reaction in the sludge, causing methane gas to be released. Given that this is a hugely hazardous environment, this is as close as I'm permitted to get. But explaining the process is sludge scientist Charlotte.
So Charlotte, that sludge that I had in a container, thick like emulsion paint, that stuff is heated.
About 40 degrees, which is optimum for the bacteria to work at. The sludge is fed in. On this side, it's held at about 20 to 30 days in there.
And that's where the fun starts.
Inside the biodigesters, special bacteria are added to the sludge. The atmosphere inside the digesters is airless, and along with the temperature, that causes the bacteria to start feeding on the proteins and carbohydrates in the sludge. In so doing, the bacteria give off a methane-rich biogas that rises up in the digesters and is piped off. It's then injected into the national grid, supplementing our supply of natural gas we drill for in the North Sea and import.
How much gas can it produce? How many homes could it heat?
Well, last week, George, we actually broke our record where we was able to power 28,000 homes from what we produced in a day. 28,000 homes.
So you could supply gas
Correct.
to 28,000 homes?
That's correct, yeah.
So the person frying their bacon and eggs in the morning might not be aware that what they're cooking with is a gas flame that has been produced by what they may have deposited in their toilet a couple of weeks before.
That's correct, yeah. It's the state of the world.
I love it.
Methane from sewage isn't going to supply gas to every home in the UK, but it can form part of a diverse suite of renewable energy sources like wind and solar that we need to provide us with power. But the beauty of methane or biogas is that it'll fuel more than just central heating and cookers. And so Zoe is heading off on a road trip to investigate what else poo can power.
What if I told you we could use it to get from 0 to 60 in under 10 seconds?
Meet the BioBug, a converted VW that runs on methane gas derived from sewage.
Or as I like to call it, the dung beetle.
With government targets committing the UK to net zero carbon emissions by 2050, I'm keen to see if methane gas has potential to be a cleaner alternative to petrol and diesel. I'm meeting sustainable transport specialist Francis Marsh, who promotes poo power as a viable vehicle fuel.
Considering this was powered by methane gas, it was a pleasure to drive. But how does it actually work?
Well, it all happens round the back here. We'll pump in the upgraded biomethane into a rear of a vehicle at 200 bar of pressure. And then we've got some gas canisters in my boot here.
It's like you're going to go scuba diving.
Yeah, absolutely. So these gas cylinders hold enough gas to go about 200 miles.
And then, is it a normal engine?
Well, if you pop the hood, we'll have a look.
Hang on. Okay. Yeah, I mean, this just looks like most car engines I've seen.
Yeah, absolutely. So it's fundamentally exactly the same, very few parts that have changed. So we've got the injectors here that are slightly different, that's a modification, and then the engine management system, which is also slightly different.
There's a global push towards electric cars, but battery technology requires vast amounts of lithium, which is a finite resource, whereas biomethane is infinite.
So does it generate lower emissions?
Absolutely, so 99% less particulate matter being emitted at the tailpipe, 90% reduction in carbon dioxide.
And I suppose being able to fuel vehicles that would traditionally be quite heavy pollutants like buses and, you know, dustbin lorries.
Yeah, exactly, but are working in built up urban areas where air quality is traditionally very poor.
you can save probably around about 150 tonnes of CO2 per year using a heavy goods vehicle on this fuel.
So this is a way in which you could actually tackle the most polluting type of vehicle and not scrap the whole vehicle, just convert the engine and run a much cleaner journey.
Yep, absolutely.
So far at Minworth, we followed the process through the Stage 1 screens where larger solids are filtered out. Then onto the Stage 2 settlement tanks where chunkier poo particles sink as sludge that's piped off from methane gas production. The water being filtered out of the settlement tanks is now a lot cleaner than when it first arrived on site. But the next process has to operate at a microbial level.
The problem is, it's full of minute poo particles too small to sink in the primary stage tanks, as well as the ammonia from our urine.
So how on earth do you remove these microelements from sewage and make the water safe enough to return to the environment? Having been channeled from the Stage 2 settlement tanks, the filtered sewage is now entering Stage 3 of the treatment process, the activated tanks. Here, in these 6 gigantic pools, incredible activity is taking place. Massive green pipes are pumping air into the sewage, churning it up like a nightmarish jacuzzi. It looks alive, and it is. The pumped oxygen gives life to trillions of naturally occurring microorganisms in the sewage that actually eat the tiny poo particles and ammonia, cleaning the water. I'm desperate to see if we can get a look at these tiny life forms under a microscope back in our pop-up lab.
I come bearing a container of the finest activated sludge, hopefully
Hi, Zoe.
bursting with living microorganisms.
Well, I'd be quite interested to see what's actually in this.
I'm taking the tiniest sample from the Stage 3 sewage.
That's a nice bit of gunk.
But by magnifying it a few hundred times under our microscope, hopefully we can see some of these tiny life forms cleaning the poo particles.
There's things moving about. Whoa, look at that.
There's something going on there.
Definitely things moving.
Oh,
Look at that.
Look at that microorganism. It's got a sort of tail part. That is definitely alive. Some sort of almost mouthpiece action I saw there.
Yeah.
Whoa!
Look at that.
Oh my word! Look at that. It's got propellers.
That
And
is
micrographics.
beautiful. So that is a single-celled organism. It's a little row of cilia or hairs at its front end, and it's basically gathering bacteria, just sucking, all the water through it.
So those almost those propellers, that turbine is
that's just hairs,
drawing
it's drawing
in.
the water in. So it's cleaning the bacteria. So this activated sludge contains all kinds of bacteria. I mean, literally gazillions of them.
In just a few millilitres of this activated sludge, we've accessed a nanoverse of microorganisms, eating up the poo particles and bacteria and cleaning the sewage.
Oh!
He's hoovered up a friend.
What's he doing? No, it's just... But that's being drawn towards it because of the water stream
yeah.
is sucking air in. That's rather beautiful. Oh, look at that.
Whoa, it's massive. Oh, George.
No, look at it.
It's a monster.
Look at the size of that.
Oh.
It's clearly hoovering up anything
It's
you get
almost
hold
got
of.
a mouthpiece.
Yeah, it's
Can
got
you
a
see
mouth.
it
Yeah,
open
yeah.
up a little bit? See, this mouthpiece here, I always wanted to go on, eat that bit. Go on, matey, get it.
These tiny aquatic life forms can be found in all freshwater and even in soil, breaking down organic matter. But now science, as we're seeing here, is able to harness them as incredible cleaning biotechnology.
George, can we track down its body? You want to see the whole length of
Let's
it?
go down to the back end.
Oh, it's a giant.
Oh, as well. Oh, look.
Whoa.
And there's the other end. There's the other end of it.
So do you...
And there's this gut, you can see the gut.
Yeah, the tract inside. It's thrilling.
And there's numerous different species with their own exotic names. These are called rotifers. There's naiadids and stalk ciliates, all hard at work. But we have to remember that this activity is occurring in millions of litres of sewage here. It's bioengineering on a mind-boggling scale. Incredibly, the microorganisms in the stage 3 activated tanks can complete their task of cleaning the sewage in as little as 5 hours.
Whilst this process continues, I want to investigate how sewage could help with one of the biggest challenges we might face in the future: the threat to our soil. In 2020, the United Nations published a report based on the work of 300 scientists. It warned that the planet's soil, vital for food production, is at risk of being degraded by a combination of factors not yet fully understood, like climate change, intensive agriculture, and deforestation. But here, sewage might be able to provide yet another resource: compost. I've come to the Centre for Alternative Technology in mid-Wales, a facility that's been developing compost toilets for 30 years. I'm meeting the centre's microbiologist, Louise Hailstrap.
What a great setting, a loo with a view. It's a space I'd be really happy to spend some time in. But it is a composting toilet.
It is a composting toilet. The different thing is there's not white porcelain and water. So instantly you're confronted with a black, dark hole. Now that's on purpose because the other option will be looking at a pile of loo paper and poo.
You're literally dumping into a void.
Yeah. So then you just use the toilet and go, no flush.
Instead of water, you add wood shavings. The carbon in the wood balances with the nitrogen in the waste. So what's left behind at the business end? How does this alternative system offer another means of resource recovery?
The poo and stuff plops down into this half of the chamber, and then once a year or once every year and a half, the whole toilet is moved to the other side, and it comes down into this chamber.
So the left is your live shit pile,
Yep.
and the right is last year's.
Composting shit pile. So the idea behind that is hygiene. So us compost workers who are having to deal with this shit, literally, are safe from very fresh poo, which has pathogens in it. After 2 years, it becomes stable or benign. So 2 years is the thing, but I know this pile's been sitting there for about 3 years, so we can have a look at that if you want.
Please, yeah.
In the sealed chamber, it's our friends, the naturally occurring microorganisms, doing the work, consuming bad bacteria and pathogens in our poo and composting it down.
I'm a microbiologist. I would not be touching this if I didn't think it was safe.
So that is human waste and sawdust plus 3 years. There's not a lot in there.
The average human poo is about 250 grams. Dry weight, that's about 50 grams. So if you think during the composting process, the poo's going to be eaten, ingested by microorganisms, and then they're going to give off carbon dioxide and water, and then eventually it's only 50 grams dry weight. So it's about the fifth of the size it was. Do you want to grab some and have a sniff?
Please. All right, I'm going to get in. Here we go. It's actually, I mean, it smells like soil. It doesn't smell in any way disgusting, but there's definitely a soily feeling. If I squeeze it together, it's slightly damp as well.
All the active volatile nutrients like the phosphorus and the nitrogen and carbon are all in there, and they've been stabilised, so they've been locked in to the humus, which is the kind of brown stuff that soil is. And they do kind of magical things to the soil. They release only when the plant needs it.
I mean, basically fertiliser.
It's more of a soil conditioner. A fertiliser is more like a sports drink for the crops, whereas soil conditioner is more like a whole food.
So a nitrogen, phosphorus, potassium, industrial, man-made fertiliser would be kind of fast food, and then this is good nutrition for life.
Here at the centre, they've applied their compost, or humanure, to enrich the soil of the apple orchard on site. They're not growing anything like root vegetables in the compost as an extra safety precaution, but food like apples growing above ground rather than in it is deemed okay. And a bumper crop they produce too.
I have to say, I find the composting toilet appealing. It solves two problems with one piece of kit. Firstly, you save phenomenal amounts of water, but secondly, you're capturing a critical resource to nurture plants with. But can it scale?
Let's face it, putting a composting toilet in every home isn't practical. But although perhaps a slightly stomach-churning idea, if we did it right, using our own excrement to help grow food is worth considering. Especially since the chemical fertilisers designed to keep soil productive use minerals that the planet is running out of, and minerals our poo and pee is rich in. So how can we scale up using our own human waste as compost? The answer to that lies back at Minworth.
Here at Minworth Sewage Works, they're extracting every last possible resource from sewage right up to the very end of the treatment process. 1.7 million people's number twos pass through here every day. That's potentially a lot of compost. I'm heading back towards Minworth's massive biodigester gas plant.
You know all that sludge that gets piped there and turned into methane gas for the grid? Well, all that poo hasn't just simply evaporated. They've still got hundreds of tons of dried solids left. And guess what they're going to do with that?
They're turning those dried solids into food for plants on an epic scale. To make it safe from pathogens, the sludge goes through an advanced system called thermal hydrolysis. It's heated to above 160 degrees and pasteurised. I'm meeting Bioresources Manager Simon Farris to find out more.
This is where we're taking the solid material out at the end. So this is everything that's left after we've extracted as much of the energy out of it as we possibly can. So what we've got here is essentially something that's quite rich in nitrogen, phosphorus, that we can actually take out onto land and use as a soil conditioner for certain types of crops.
This looks absolutely fantastic. I mean, it's black gold, isn't it, really?
Yeah, essentially. So loads of stuff that the world is running out of right now is still containing that.
Slight ammonia whiff, not too much.
There's a little bit of an ammonia whiff, but that's some of the nitrogen that's in there that we can actually use to replenish some of the soil and condition it in the way that we want to.
I would have no qualms about eating a root vegetable or a tomato or whatever that had been grown using this. Is that a general feeling, or are people alarmed about it in any way?
So there's a huge amount of legislation at the moment that governs what we can and can't take out to land, and it's quite tight. Particularly here in the West Midlands, we've got zinc from galvanising companies, and there are other heavy metals that come out of industry that come down the sewer to us. And what we have to do is we have to make sure that all of those stay within very tight constraints in a way that we can ensure how it's used is safe for public consumption.
The end result looks much the same as the compost Zoe had held in her hand, but it's not as pure. The reality of our everything-in-it sewage system means that although it can be applied to farmland, like this field near Minworth, its use in agriculture is limited, strictly not for farm-to-fork produce.
In the UK, though, it's mainly used to grow crops like this oilseed rape, which are then turned into animal feed. But all the nutrients are there in our waste. The nitrogen, the phosphorus,
the vital resources to feed the soil, to feed us. Arguably, we've taken our soil for granted for too long. But by being more careful about what we send into sewers, then we could have a renewable resource available to keep replenishing some of our soil with the nutrients it needs. Using our own waste for agriculture and energy is one thing, but can science go even further? Might sewage be a secret resource for revolutionary health benefits? Earlier, Dr. Ellie Jimmerson went fishing in the raw sewage here at Minworth in search of phages, nanoscopic entities that can kill deadly superbugs like E. coli and Klebsiella. And I'm keen to see what, if anything, she's managed to isolate in her sewage sample.
Ellie, I'm very excited. You've been on a phage fishing expedition. What have you found?
Yeah, so while we've been hunting for phages, we've taken the water from Minworth and we've filtered it so to get out the cells that were in the sewage. So take out bacteria, any human cells, any debris that's
So
in
all
there
it
as well.
leaves behind?
It should just leave behind
viruses.
phages and viruses. So yeah, then we can kind of look at those a bit closer. So and when you look at it under the transmission electron microscope, you can see these phage particles. So these are some of the phages that we've got from our sewage.
So have you any idea what these are? Are these new ones?
So
or ones
yeah,
you
these
know?
are new ones that we've never looked at before.
So, a result, new phages found in sewage. But did these ones have the power to act against deadly superbugs like E. coli and Klebsiella?
From that, then I've taken my cultures of E. coli and Klebsiella and I've added some of this filtered sewage into it. So these are some of the E. coli on its own, and we have found that there are some phages in there. So,
show me.
So if we hold it up, there's a few little faint spots. So they're really round spots. These are where the phage plaques are. So where those phage have eaten away at that lawn of bacteria.
Oh, yes. So you know that there was a phage in there that has killed the bacteria. That's brilliant.
We can't pick up these tiny holes on camera, but under the microscope, the effect of the phages on the E. coli is dramatic.
So
All
that's
of this
a big
yellow.
hole.
Yeah. That's like a lawn of the bacteria around the edge with just this giant big hole in the middle of it.
Can I just get my head around this? You have isolated a new sort of phase from the sewage there.
Yeah.
And it's active against E. coli.
Yeah.
I mean, this is big. You have discovered a biological entity which is potentially a lifesaver.
That's a good day's work.
Where do you... A good day's work. This is groundbreaking stuff.
Yeah, it is. Yeah, every new one that we find is another patient that we can potentially treat. So yeah, these are really exciting results.
But how long do you think it'll be before this sort of treatment is available on the NHS?
So on the NHS, well, that involves these big clinical trials, which often take maybe 10 to 15 years to come to fruition. So there's this big lag, but what we're hoping is to get some trials set up, some use where we can use them in palliative care and that kind of stage.
So there's still work involved to establish if this new phage is indeed life-saving and becomes mainstream. But when permission's been given to use phage treatment in the past, it's had remarkable success.
At Great Ormond Street, where they treated a patient who had cystic fibrosis, she'd had a double lung transplant and then got a bacterial infection afterwards.
And was obviously very vulnerable.
Very, very sick, very ill, yeah, very vulnerable already. And she'd been sent home on palliative care.
That means it's the end.
That's the end of life care, yeah, just make her comfortable. And then since having phage treatment, she's actually got back that quality of life and she's been able to return to school.
I mean, that is just, that's the grail, isn't it?
Yeah,
That is just...
That's why we're targeting these superbugs. E. coli and Klebsiella are really important superbugs in the hospitals. So to have something in the arsenal that we can actually treat them with would be amazing.
For me, Ellie's discovery is the most astonishing of all the resources that sewage has to offer, completely at odds with our natural reaction to it as a substance that's quite simply disgusting. But of course, it does need cleaning And now Minworth sewage is reaching the end of its journey through the plant. The microorganisms in the stage 3 activated tanks have nearly completed the job of eating the poo particles, bacteria and ammonia in the sewage. And senior technician Phil is getting Zoe a sample to see the results of this extraordinary bioengineered cleaning process before it goes on to the final stage.
That should settle now.
All right, let's have a closer look. That's amazing. In just that short amount of time, stuff is settling, and you can see these little micro currents. It's as if something's dissolved. Look at that.
We want to clear water at the top and the solids at the bottom.
Because actually, at the moment, this has been very agitated, so it's not going to look as clear as it really is.
No, it'll have a lot more time to settle in there. We're picking it up, we're moving it about. You take a final effluent sample and you'll see the clearness of it. It looks like you just bought it from the supermarket or out your tap.
It's amazing how powerful microorganisms are at just breaking things down and treating things as food and naturally cleaning our water.
The sludgy solids at the bottom, full of microorganisms, are introduced back into the activated tanks, whilst the clearing water at the top is channelled to Minworth's final tanks. After a last stage of settlement, the water being filtered off looks like this. Clear and deemed safe enough to return to the environment. Incredibly, it's piped out of the site and dilutes into the nearby River Tame. Then joins the Trent, the UK's third longest river.
Well, Zoe, was that fun?
Enlightening.
What it has done, it's totally changed my view of a sewage works. You know, I mean, it is an incredible entity.
Completely. The sheer volume of liquid and solids that arrive here every second, thousands of litres of the stuff turn up here continuously. It's a machine for dealing with this tsunami of stuff. To go from kind of mechanical engineering when the screens churning through and taking out the rag, to then the bioengineering on that microscopic scale and seeing the world inside that activated slurry. And you realise that's an incredible ecosystem that's alive.
We saw it on the screen. All those little animals, I mean, literally gazillions of them. I mean, they're working for us incredibly hard.
It's cutting edge stuff, actually, what they're doing here, supposed to on this.
What this investigation has revealed is that a sewage plant like this, using the very latest biotechnology, can be a secret gold mine of fuel, of vital soil conditioners, and even of life-saving new treatments. We might not be at the stage of going for a number 2 and filling up the family car with it yet, but in this brave new world, the secret science of sewage is only just getting started. How do microbes affect our health? To explore the science of what lives in us and on us, go to bbc.co.uk/secret science of sewage and follow the links to the Open University.
From surfing to survive to the hunt for Gaddafi's billions, press red now for over 36 documentaries, the Storyville collection on BBC iPlayer.